All right, welcome everyone to walkthrough 3. P-set 3 is a really fun one. It's a new one to CS50 called Scramble. So if you've ever played Scramble or the similar board game Boggle, essentially it's a game where you have a grid of letters, and in the time allotted you need to find as many two-letter or longer words that exist on the board. And so there are certain rules, such as you can only use one letter in the grid, one block in the grid once, and you can't like go back to it. You can only move construct letters by linking together the adjacent letters. So this is going to be a really fun P-set. So let's look at our toolbox. So again, the appliance is still being updated, so make sure every time you enter the appliance to open your terminal window, and in the terminal do the command sudo yum-y update. This is important also if you want to be able to run the staff solutions, which we definitely recommend. Sometimes it's good once you've finished your code to test it against the staff solution, make sure that everything you enter into the staff solution, whatever comes out there, same thing that happens with your code. All right, so make sure to update your appliance. Now also, since we're dealing with a grid in this case, we're actually going to be delving into two-dimensional arrays. We've dealt with one-dimensional arrays, but now we're going to extend them so that they have multiple rows as well as multiple columns. Then we're going to definitely be using functions in this P-set, basically sending, calling a function, sending some parameters out, and then getting a return value back. And in Scramble, we're not asking you to actually make the whole thing from scratch, but rather we're actually giving you something called distribution code. So functions that we've already written that kind of lays out the skeleton of the P-set, as well as implements some of the tougher things that that you'll definitely be able to read over and understand, but don't need to quite make it yet. All right, so to quickly rehash over the one-dimensional arrays. Arrays are data structures that hold multiple values of the same type. And as a reminder, these arrays are zero indexed. So most of you are probably familiar with an array such as this. If we wanted an int array with length 3, then we could initialize it by having an int values and then the square brackets indicating the length of it. And then we would assign values to the specific elements within that array. So here we have an int array with the first index at index 0, 2, index 1 is 4, index 2 is 6. Now say we wanted a larger array and to hold multiple values. Well, then we could have a 2D array. Now this is very similar to our one-dimensional array. It's zero indexed, so that means that the first column is indexed at 0, the next one is at 1, and then the next one is at 2, and then similarly we have rows. And so you see that when we declare our array, we also, just like before we indicated the size of the array, we also similarly indicate the size, where the first bracket indicates how many rows you have and the second one indicates how many columns. All right, so in this P-set, you'll want to be able to iterate over the 2D array, access every element, be able to access every element in this 2D array. So essentially, we want to reach all possible combinations of the row and column values. We want to reach the row 0 at column 1, 2, and 3. We want to reach row 1 at column 0, 1, and 2. All right, so we have to kind of have some kind of structure that allows us to iterate over all of the rows and all of the combinations within, and all of the combinations of columns within that. Okay, all right, so here I have a 2D int array. It has 3 rows and 3 columns. And so this is kind of the quick way to define the whole 2D array. I'm saying, so the first row is going to have 2, 4, and 6, kind of similar to the previous example in the slide. Then I'm going to have the second row be 3, 6, 9, and then the third row is 4, 8, 12. All right, so we have our 2D array, and we know that it looks like this. We have 2, 4, 6, 3, 6, 9, 4, 8, 12. All right. So now if we add in the indices, this would be row 0. This would be row 1. This would be row 2. Similarly, we have column 0, column 1, and column 2. Yes?
Which tree is the column and which one is the row?
So the columns are these ones. So your columns are these ones. This is column 0, this is column 1, this is column 2.
I mean, in the declaration in table 3.3.
So when you're declaring the you're declaring the 2D array, then the first number in the square brackets is going to be how many rows you have, and then the second one is going to be how many columns. Great. Okay, so we want some kind of structure, some kind of loop, right, that's going to give us every possible combination. So say we start by saying, okay, so to access anything in this row, let's just look at this row for now. We know that so these are rows here. We know that our row index is going to be 0, right? But to access this element, it's at the 0th row and the 0th column. So then we would access it by the index of 0, 0, right? Then this one, similarly, is still on the first row, but it's on the second column. So we access that by 0, 1. So then the last one, right, would be 0, 2. So whenever we're at a specific row, we're going to want to iterate over all of the possible column values, right? So let's start with a for loop that starts at 0, goes to the length of how many rows we have. All right, so this is cycling through every row. Then what we want to do is, within that, now that whenever we're at a specific row, we want to cycle through all of the available columns. So then we'll have another loop. Let's call it J. I, J, and K are very common row indexing kind of loop variables. So be sure to, you can use these if you like. Also try to avoid then, if these variables are commonly used in loops, try to avoid using them in as variable names for other things in your code, just because it's common convention to use I, J, and K for just within the loop or indices. Okay, so then here we have a for loop that iterates over all of the rows. Then every time that it's at a different row, we'll iterate over all of the different columns, right? So this way we can actually get to every possible combination of 0, 1, and 2 with 0, 1, and 2. That make sense? So this way we're able to access over every value. Now we could have chosen to do columns first as well. It really doesn't matter as long as you iterate through all of the columns and all of the rows. All right, so now let's do something with these values. So let's say print. Now let's print their integers. And then the variable at that place is it's going to be a value in table. Now the specific row index would be I, right? Because we use that to iterate through our rows, and then J to iterate through our columns. So now let's make 2D. Now when we run 2D, it prints out all of the values in the order that we specified above. So you see that it goes through all the rows first. So it's at row 0, and then it prints all of the values within that row, and then continues. All right, so that's an example of a way that you would iterate over and conduct actions on values within a 2D array. Great. Now what we'll see in the distribution code is many functions. And so some of these functions will be Boolean functions where they return a Boolean to you. Some will be integers, for instance. And so essentially to review functions a little bit, basically functions have a return value, a name, right, with which you use to call the program, and then they can have any number of parameters. Essentially, when you call the function within the next function, basically saying, okay, now I want you to execute this function, you have to pass in certain values. So in this case, our function foo would have to take 2 integers. And within that function, then, it would be able to access them, refer to them as x and y. So a similar example is the is upper, is lower functions that you may have used in your crypto program. And so essentially, those functions were already written for you, but depending on their return type, you could use them within the functions. So say you have a Boolean function called foo, then you could use that because you know that it will represent a Boolean. Essentially, when you call it, it'll return back a Boolean, so you can kind of treat that as, okay, this will represent a Boolean. So within your condition, you can simply say if foo, and then you pass in its required parameters, 5 and 9, for instance, 2 integers, then you know that that will return either true or false. And so then you can use that as your condition itself. Similarly, you could also say foo 5, 9 equals true or equals false or something like that, but that is slightly unnecessary as the Boolean, as the function itself already evaluates to either true or false. Okay, so we're going to keep this in mind when we see some examples in the distribution code. Okay, so back to Scramble after we have 2D arrays and understanding functions under our belts. Okay, so in Scramble, essentially you're going to have a grid of letters. And then you're going to help implement a program whereby the user can input different letters that they see on the grid. So that also means that you're also going to have to draw the game board. Then the user will be inputting certain words, right? But you have to check A, whether those words are valid in the dictionary, or B, whether they actually exist in the board, can be found in the board. So then in the distribution code, we'll go over that in a sec. You'll see kind of what's already made for you, and then within the given structure of this distribution code, add the functions. There are certain functions that are left empty. There are certain functions that you just have to add to. So certain functions that you're going to be working with is draw. So you have to implement the draw function, actually drawing all of the letters on the board. You're going to have to implement the lookup function, whereby you have to check whether the string that the user inputted is a valid word. And so then, as I mentioned before, that includes whether that's in the dictionary or not, as well as whether it's a valid game move. Then you're going to implement Scramble, where in the game, if the user, for instance, they're having trouble finding any word, then if they type in Scramble into the prompt, then the game board actually rotates 90 degrees, keeping the same letters, but just rotating 90 degrees clockwise. And then finally, we're going to deal with case insensitivity. Essentially, when all of the words in the dictionary included in the Scramble, included in the distribution code, is all stored as uppercase. But we want to allow the user, for instance, if they enter in a mixture of lowercase and uppercase or just lowercase letters, then if that word is valid, then they should be able to get points for that as well. Okay, so distribution code, it might be a little tough to get through at first. You might not want to read all of it and just get straight to writing your program, but please do read it once, read it twice, read it thrice, read it over and over again so that you have a good sense and can feel really comfortable with the code, even though you didn't write these functions yourself, that you kind of know what they're doing and you can kind of expect the way that they might interact with the functions that you will implement. So without further ado, let's actually get into this distribution code and I'll help you guys make sense of it. Now, I've already downloaded the distribution code. You can do this. There's instructions in the spec where you have to make your own directory for pset3, and then if you execute a command that's found in the spec, then you'll be able to download the words file, which contains basically the dictionary file. If we just look at that quickly. It essentially contains a whole list of words that are going to be our dictionary. Okay, so let's start at the top. Also here you'll notice that style really comes in, the good style of this distribution code comes, is to our benefit because we can see comments that kind of explain how the code's being used. Okay, so we have this, including our libraries. Notice that here we have include time.h. And so that library allows us to keep track of time because Scramble, you have to essentially enter in as many words as possible within a given time frame. Great, so here we have some variables. So the duration of the game, we've set it to be 30 seconds. We say that the dimension of the grid, it's a square grid, is going to be 4 by 4. We say that there are words, number of words in the dictionary, that any word can only have a maximum of 29 letters. Then here's a file called log. Essentially, we're going to be automating some of the results from your code. So try not to alter anything to do with log because we'll be dealing with that. You don't have to quite understand that yet, but just try not to alter anything to do with log. Okay, so notice that here, this variable grid, which is a 2D array of characters, is declared outside of our main function. So this is what we called a global variable. Because we're dealing with a game here, kind of if you recall all the way back to scratch, when we had something like a score, for instance, when we were dealing with a game, that kind of had to be accessible to a lot of the various scripts. So similarly, we have this variable that needs to be accessible to a lot of the functions in our program. So grid here is a 2-dimensional array that will store the letters in the Scramble game. Later on, we'll see the use of this later, but then we also have a 2D array of Booleans called marks. And so essentially when we go into checking whether a word is valid or not, we kind of need to know whether we've visited a certain block, visited a certain letter. And so then marks basically is going to contain either true or false at a given index. So it'll kind of let us know whether we've been there before, whether we've visited that letter during our certain check. And so so marks, as you'll see later on, will essentially it will exactly mirror the grid. Great. So here we decided that we wanted our own data type. We weren't happy with just string. We actually wanted something called a word. So we have this typedef struct here, and then within it, it has a Boolean called found, so whether this word has been found or not. Then it has an array of characters, essentially the actual word that it is. Now then, word is an actual new data type that we've made. So we can have an array of words, for instance, or we can make a new word and have multiple instances of them. But we only have one dictionary, and so that's why we only have a struct called a dictionary as opposed to a typedef struct. So the struct has an integer with the size of the dictionary as well as an array of words. And again, we use this global variable words, which is defined above, to be the number of words that's actually in our dictionary. Here we have a whole list of prototypes, function prototypes, essentially saying, okay, so now you can expect to have all of these functions later on in the program. I'm going to have a void function called clear, a Boolean function called crawl that takes in a string and then 2 integers, etc. So you see these here. Also a nice feature in gedit is that along the side here, if you make sure that you've selected this functions tab here, the source code tab, then it'll actually show you all of the functions that you have in your program. It'll show you several things that you can use. For instance, here it has that you've defined a new data type called word, and then the certain global variables that you have. But this functions tab is quite useful because you can click back and forth and kind of jump to the specific points in your program. All right. So we're at the main function now. When the user enters in the command enters in a command, basically they can either say /scramble, or they can also enter in a number after that to basically indicate which board they want to play with. Usually whenever you only enter in one command line argument, then it's just going to give you a random board. But say for debugging purposes, you want to make sure that you just check the same board over and over again, then what you can do is just say /scramble1, for instance, and it'll always give you the same board. So here it's ensuring the proper usage. So if the user enters in more than 2 command line arguments, then it will, instruct them on how to properly use the program and then exit. Now here, if argc is 2, that means if the user has inputted a number of the specific board that they want to use, then essentially when the program later on makes a random board, then we essentially are giving it a seed, kind of like forcing it to use a certain value. Okay, then here we load our words file. Basically if it can't open the dictionary, if there's something goes wrong, then it'll return 1. So we initialize the grid. We'll look into that function later. We set the score to 0. We calculate when the game will end. So that's 30 seconds as we set. Then here again is the log file, which you don't need to alter. All right, so here's kind of the meat of the program where we have a while true loop. So notice that if you just have a while true loop by itself, then it'll just keep on executing whatever is in its body. But as you'll see later on, we actually have a break. So we actually allow it. We have some way of it actually breaking out of the function and not executing forever. Okay, so first what happens is the screen will clear, right? So that you can draw a new board, and then it'll have the function called draw. Again, it'll log it. So essentially every time that it goes through this loop, it'll report the score to you, check whether the game should be ending, whether you're out of time or not, and then report how much time you have left if the game is still in play. So then here we have a prompt for a word, and then we have the getString function. So then that's where the user actually inputs a word for you. So then essentially if they've actually entered a word, if it's not null, then you'll want to, then the program will log it. Then you want to check whether you need to scramble the grid. So basically if they enter in the command scramble, the word scramble, then it's going to rotate 90 degrees. Okay, then otherwise, if it's not the word scramble, then what you want to do is you'll want to look for the word. So the find word is true. We'll go into that function later, and then you'll want to look it up. So basically, is it on the grid, and is it in the dictionary? And if it is the case, then it'll increase your score by the number of letters that word is. Okay, so that's our main function there. This here is essentially like an escape code, so you don't need to worry about that quite so much, but essentially whenever you call the clear, it will kind of clear the terminal and move the cursor back and kind of erase whatever it had written before. So let's not go to crawl quite just yet. Instead, we'll scroll down and see the draw function here, which is your job to do. Essentially, you have to print the grid in its current state. So we've already taken care of actually initializing the grid, and so you don't need to worry about which letters to put in the grid or something like that. But in the draw function, you're going to want to print out whatever is in the grid. Then here we have a Boolean function called find, which we saw above in the main function. Essentially, it if the word was found and also was looked up in the dictionary, if both of those returned true, then it would increase the score, right? So here is the find function, where it takes in the word as a string, and it has to be more 2 or more characters. And then essentially what this does is it searches the grid for that word. So here we see an example of iterating over every element in the grid, where they iterate over the rows, and within that iterate over the columns. Here, remember the marks 2D array that basically stores either true or false, whether we've been to that letter already. Well, essentially this resets all of the marks because we only want, we're only dealing with marks every time that we're checking a specific word. And so then here, once we've reset all the marks, is that it actually searches for the word. And so to search for the word, that's where we use the crawl function. So let's go back up to crawl and take a look at it. All right, so what crawl does is it takes in a string called letters, as well as basically x and y, which are the indices of that, which is the starting index of where the user has said the word is. So essentially it checks, well, if x is less than 0 or more than the dimension, basically that means that that index actually doesn't exist in our game, so then that returns false. If you've already visited the specific letter, then that's going to return false as well, because a rule in Scramble is that when you have a letter here, for instance, you can join a letter by going up or diagonal like this. So basically your next letter can be at any of these adjoining blocks, but what you can't do, for instance, is go to this letter and then go back to the A. So you can only use each letter once. So then that makes sense that here are marks. If we've been there before, if marks is set to true, then, well, that's not a valid word. Then what it does is it checks, it says, okay, well, I'm going to check whether at this specific location the letter that we want is there. If it's not, it returns false. Since it's already checked that block, then it's going to set the mark at that specific point as true. All right, so now it checks that, like, you know, basically if we're continuing, that means that we're going to search for the next letter in the word that the user is trying to submit. So here we're called back to the rules. Basically, you're trying to check all adjacent values, the ones above, below, left, and right, as well as the diagonals. And so similarly, when we thought of iterating over 2D arrays, where we wanted to basically iterate over every possible and check every possible permutation between the row indices and the column indices, here we want to check every possible combination, if it's to the left of the letter, directly above, or to the right. So here we see that this loop checks to the left when I is -1. When it's at 0, it checks basically at the same column that the letter's at, and then if I is 1, which is its final value, then it checks to the right. And then that's not enough, right? We need to check all of the kind of vertical values. So then here we have a loop that checks whether it goes below, at the same level, or above. So then the combination of that will basically access every single adjacent block to A. However, it also checks the block here at A. So then we want to make sure that we don't check that one, right? Now then, to actually check whether the preceding words are valid or not, then essentially we want to basically do the same process for the rest of the word, barring the one that we've already done. So then here is a recursive function. So basically it calls itself, and we'll get into that a bit later, but essentially it conducts the same process for all subsequent strings. Okay, so we've kind of talked about the find function. We understand what it's doing. It's basically checking whether this word that the user gave actually exists on the board and whether it's a valid move. Here we have an initialize function. Notice that it's void. So essentially it's not going to be returning us anything, but it's just going to be doing something for us. So here off of Wikipedia, there's a frequency for every letter of the alphabet based on basically how often it's used in the English language. See that E is, for instance, one of the most popular letters used. So basically we want to populate the grid. What this function does is populates the grid with letters based on kind of relative to their frequency in this array. Now this is using this kind of syntax, this language here saying size of frequencies is, it's kind of only in this specific case we can actually use size of frequencies. So when you actually want to find the length of array, you probably aren't going to be using size of, but rather just like using the array length. Well, you can ask your TFs to kind of talk to you a bit more about that, but essentially just know that this syntax here is kind of more of a special case. All right. So now basically for every element in the grid, we want to make a letter, and this is going to be pseudo-random. So random, but not quite. So essentially what this does is we set a new double with a random value between 0 and 1. Based on that, we're going to map that. So say that, D is set to 0.6, for instance. Then we're going to kind of, if D is kind of 60% in, then we're going to look at all of the letters and kind of find relative to how often they're used, well, what's 60% in? So this isn't just 60% of the alphabet, but rather, A takes up this much space, and then B takes up this much, and then E, for instance, will take up this much. So based on kind of the relative lengths or the frequencies of these letters, we're going to kind of map that random value between 0 and 1 to a specific letter. So that's what this code does here. And then here essentially K is kind of like the shift of how, where along in the letter we want to be. And so we set the character in the grid to be A plus K. Notice that in back thinking to greedy, we kind of had to use the round function to deal with floating point imprecision here. So similarly, we had to take into account that sometimes floats aren't exactly what we intend them to be. So we want to kind of make a catch for that. Okay, then here we go into kind of file I/O, basically reading and writing to files, which you will get into later, but not quite yet. So essentially this opens a dictionary file, basically reads what's in it, and then sets it into an array. Notice that we set it into the struct that we've declared, the dictionary struct. And so dictionary has an array called words associated with it. So what it's doing is saying, okay, so dictionary, the words at this particular index is such and such value. All right, so then we're almost finished with the distribution code. We finally have the lookup function where you have comments basically instructing you on what that code should do. So basically lookup will look up a word in the dictionary, and as long as that word hasn't been found already, then flags it as found so that the user can't use it again, but also returns true. Thinking back to the main function again, returns true, so says that that word can be scored. And then finally, you have the scramble function, which is another void function because it's essentially doing something but not returning anything. So what the scramble function will do is rotate the grid 90 degrees clockwise. Okay, so I know that might have been a little rough, but it's important to do. Watch me going through the distribution code, but as well try to go through it yourself. What I like to do is kind of map it out, so to understand kind of what does this program with all of these functions actually do. So if I were to go through the distribution code again, now that I kind of have a sense of what's going on, then I would say, okay, so we start with our main function, right? And then I think the first thing that it does is it calls load. All right, so main calls load, but load is a void function, so then what I kind of do to indicate that is just putting a single single arrow pointing to load because main calls it. Next thing is initialize. All right, so main calls initialize. And then if we look back into our main function, I think this next thing that it does, the next, like, right here, I mean, there are tons of different functions that main is calling, but right now I'm just focusing on the most major ones relevant to the code, so I'm not like including A to I or stuff like that. Right, so then the next thing that it does is it clears it, and then it has draw. And so I know that draw is something that we're going to do. So that's the draw function. Later on, we see that if we, the next one is a bit, oh, okay, so then we have scramble. All right, and then we have find, right? So find's another function. We see that find is, if you recall back, it's a Boolean function. So that's actually going to return something back to us. So then here I indicate that by, we have find, and then we also have so then we also have lookup. But then remember that there's also this crawl function, right, that doesn't seem to have been called in main. So that means that some other function is calling crawl. And if you search back through the distribution code, you see that find here is the one that uses crawl, right? So then find then also links to crawl, which is a Boolean value, which returns something. So I'm adding another thing. And then since crawl is recursive, it also kind of loops back on itself. So that if you see here, I've kind of drawn a picture of what our program kind of looks like. So understanding the relationships between certain functions, and kind of going back to that, you also see kind of the order of the game and kind of the logic of how the game program is going to proceed. Okay, so we've read the distribution code. All right, so the first function that you're going to want to implement, or one of the functions that you want to implement is draw. And so here, you actually have a little bit of freedom with this. If we look at the staff solution, I'm going to open the terminal window, actually. Set 3 scramble. Scratch that. I think I need to update my appliances. So if you play with the staff solution of Scramble, instructions are in the spec for that, then you can kind of see how they've printed out the game board. But essentially what they do is they just put spaces between each character, but you have a little freedom with this, so if you want to print like lines, for instance, between them, then you can do that. So you want to think back to how we iterate over all elements of a 2D array, and you'll want to kind of print those, make sure that you have your loop and have your print functions such that you're printing in like the right, printing in the right order, right? So if you want your iteration loop to kind of, when you iterate over it and use the indices, make sure that you're kind of like printing in the right order. Okay, so dealing with 2D arrays at first can be a little confusing. So here on this slide, basically I've made a table that shows you, for every given spot in the 2D array what the indices are. So if you want to like refer back to this for just a quick check or for a reference or something like that, then you can use this. Essentially, the columns are in blue and the rows are in red. Okay. So the lookup function is twofold. Basically, lookup, it is a Boolean function. It'll tell us true or false whether basically that word can be, that the user submitted word can be accepted as a valid value. And so a word in Scramble is only valid if it's found in the dictionary and if it's actually found in the board, right? And so remember that lookup, essentially, you have to implement this by yourself. So try to, you want to basically check both things, whether the word is actually in the dictionary and whether it's been found already. Recall back to the global variable dictionary, which is a struct that we've made that basically has an int called size associated with it, as well as an array of words, where word is a new variable, a new data type. So to access, like for instance, the size of the dictionary or the words array, then what you can do is actually just write dictionary.size, similar to the way that you would just use any other variable. So if dictionary.size represents the size of the dictionary. Similarly, dictionary.words represents the array. So if you wanted to access a certain word within the dictionary, then you would have to put, you would have to add an index, right? Because you would have to say dictionary.words at index I, and then do something based on that. So knowing that the dictionary has a certain size associated with it, as well as an array of words, to check if something's in the dictionary, then you would have to iterate over the dictionary, right, to check whether that word is found. Now, if you think back to lecture and we talked about the different ways to search for things, then remember that linear search probably isn't always the best way to go, but it definitely is one way to search for something. Sometimes you might find that you implement your find function with linear search at first and then get the rest of your program going, and then later on you can go back and kind of alter the way that you search through for a word. Okay, so that tackles, basically knowing how to access the words array of the dictionary. That kind of tackles looking to see whether that word is actually in the dictionary or not, but then we also need to tackle whether that word is actually on the board, right? And whether that's been found already. So we actually already have the find function, remember? It shows that to you, but what is a word? This isn't a philosophical question, but rather look at the type definition. So we have a Boolean called found, as well as the array of characters that basically represents that word. So when you return lookup, you will want to check whether that word has been found or not. Now, looking back to see, knowing that the Boolean found is the name of the Boolean that's associated with every word, then how might you access that variable? Thinking back to how we accessed the variables within dictionary. So here we had dictionary and then we said dot size, right? So similarly, when we have a word, and in this case, be careful because word is just any other data type, just like an int or a string. So we'll want to, so you can't actually just say word, right? You're going to have to, unless that's the name of it, you're going to have a variable with a name, and then once you have that, say that's called like foo, for instance, then you can say foo dot found, and that will return you the Boolean value of whether that word has been found or not. Okay, so then the next part of the P set is to implement Scramble, whereby whenever the user inputs Scramble, and that's already been dealt with you in the distribution code, essentially you just need to implement the function Scramble that basically has already instructed you to rotate the board 90 degrees clockwise. So as per the spec, the instructions say that the board rotates 90 degrees clockwise such that the value at grid 0, 0 then moves to grid 0 and then dimension -1. In this case, for Scramble, our dimension is 4, so then 0, 0 would then map to 0, 3. Okay, So let's draw this out to see what it might look like. I'm not going to do a 4x4 grid, but rather a 3x3 one. So let's say this is an int 2D array. I'm going to just have all right. So say we want to scramble this. We want to rotate it 90 degrees clockwise. We know that as a starting point, the value at 0, 0, which in this case is the number 0, is going to map to row 0, then column dimension -1. And so that, in this case, the dimension is 3. So then 0 would then move to row 0, column 2. So we have the number 0 there. So then if you were to, so basically essentially what we're doing is we're like taking this, physically rotating it, so then the 2 would then go to this corner, the 8 would then go to this corner, the 6 to this one. And then the rest of it would look like this, 0, 1, 2, and then. So that's what a grid looks like when you have successfully scrambled it. So when you're implementing the scramble function, what you want to do is kind of see, okay, well, how can I like replace these values? Is there some kind of pattern or some kind of formula to determine where a particular index goes? So for instance, I might look to see that like 3, 4, 5 here is a row. Where else do I see 3, 4, 5? Well, I see it here. Similarly, I see 6, 7, 8 as a row, but then it's actually a column here. So that's the pattern that I see right now. There are probably a few other ones. So based on that, try, think of some kind of pattern, some kind of way. Once you've identified one, then you're going to want to basically reset the values in the grid, right? So grid 0, 0 will become 6, grid 0, 1 will become 3. But remember that you'll, for instance, if you reset this right away, say grid 0, 0 equals 6 now, then you, or sorry, you say that grid 0, 2 becomes 0 now, then you kind of lose what 2 was there. So thinking back, it's not enough to just reassign right away, so you'll probably want to make like a temporary copy of something before you actually put it in the right place. All right, so then, right, so the last thing is to implement case insensitivity. So if you look back, search to the spot in the spec where the user inputs a string. If you recall back, thinking back to, oh, I erased the map. So if you think back to the map of your program, then it's within the main function, right? So look to where you're dealing with the user inputted string, and then within there, think of the tools that you learned from your crypto pset, pset 2, and then think of ways that you might be able to allow for user input as mixed case. So, they could have a mix of upper cases and lower cases, but that should still be valid. In the dictionary, recall when we opened up that file, every word was stored as all uppercase, but we don't want the user to have to input uppercase all the time. So can anyone think of a way that we might be able to kind of allow the user, even though they inputted all lowercase, for instance? Yeah.
You can make it to upper?
Yeah, exactly. You could make it to upper. So you could convert all of the letters to uppercase, and then that way you ensure that that is going to be an exact copy of whatever's found in the dictionary, if it's in the dictionary. Great. Okay, so we have a little bit of time left. So some things that you might encounter in this pset is kind of a need to know like what your variables are at a certain like point in time. Because in the spec we have the clear function that basically clears whatever you've drawn on the board and then kind of erases it all and then rewrites on top of that. You might, while you're writing your pset, not really want that to happen, right? Because you want to see, okay, once I enter in this scramble, for instance, once I enter in scramble, like what does it actually, like what does it do? What was it before, just for reference? So then what you might want to do is go back to your main function and comment out clear, for instance. So then when you run your program the next time, your program won't clear it instead and will actually just keep on printing on top of that. There are some other ways to debug as well. What you could do is you can include printf statements. I think one thing that I saw in psets that I graded was that people included printf statements to kind of print out variables at like a certain point in time to kind of keep track. But just make sure that at the end, once you've finished writing all of your printf statements for you to keep track of things, that you comment them out afterwards, right? Or delete them once you've finished. So that's another way that you could do something. You could just write in a printf statement somewhere that's relevant and then kind of see, based on what the terminal prints out, what that variable was. Another way to do that that we'll go into more detail during lecture is GDB, which is kind of a debugging tool. Essentially, when you run it, it'll go into your program, and you can basically have it advance like a single step at a time instead of evaluating everything. So then you can kind of break it up into little steps, and then based on the way, and then along the way, kind of print things and see what the values are, and that kind of helps you figure out where a bug in your code might be. So what we could do right now is write a quick function and then see how we might be able to use GDB to kind of see what's going on. So let's have an int main, and then what do we have as parameters to main? We have int argc and string argv. All right. I'm going to save this and walk through as gdb.c. All right. I'm going to have return 0. All right, so how about let's just have a simple for loop. Let's have 12. Let's also have an int, for instance, named counter, and we can start that at 0. Okay, so at every point in the for loop, let's say that we want to increase counter or like multiply it by whatever I is, for instance, okay? All right, so this is a pretty short function. Let's make GDB. Oh, and then Clang is smart tells me that I didn't include cs50.h. Okay. All right. So now we want to okay. Actually, sorry, Chris. I'm going to rename the file just because it's a bit confusing. Okay. All right. So now what we want to do is we want to start GDB. All right, so then I said GDB debugging, so essentially it's going to be set to kind of like focusing on this debugging, the debugging file. I'm going to put a breakpoint. Essentially, the program is going to run until it hits like a certain breakpoint. I'm going to say break at the main function. All right, so now I'm going to run debugging. So essentially, inside GDB, I can run the code. All right, so it's running the program, and even though main was kind of one of the first things that we wrote, we also have the include files. So there's like stuff going on already. It has the breakpoint at main. So now let's say next. So okay, we can continue on. It says int counter equals 0. I'm going to say print counter. This is strange. So essentially, we expect counter to be 0, right? But essentially, GDB is kind of one step back. So whenever you say next, it says int counter equals 0. That's the next thing that it's going to execute. So then you can say next again, or you can just say n, for instance. And now if you print counter, counter is 0 as we expect. Basically, it creates its own kind of variables for it, but essentially whatever's there, like right here, that's what counter represents. All right, so I'm going to click next, and I want to know what I is. You'll print I, for instance. I is 0 as we expect. And then next again, it's indicating that it's going through the for loop again. So if I print I, for instance, I can see that we're on that I is 1 currently. So that's like a way that if you set a breakpoint at a certain function and then keep on going next and then checking what I is, if you have a guess that maybe somewhere, somewhere something's not happening as it should, and you suspect that maybe it's at the first index or the last index or something, you can use GDB, keep on printing I to be able to check what those values are. Right, and so then in GDB, because print and next are such common arguments, common commands, just like I abbreviated next to n, I can also just say p counter. That's still 0. Then I click next. I want to print counter again. Oh, so that's still 0. And you're kind of wondering, well, I want counter to basically be like kind of like a factorial function, right? So why, just like in just general techniques of debugging, why might that be? Why is counter not increasing its value? Why is it staying at 0? Well, here I have, back in here, I say counter equals counter times I, right? So then if I go back to the beginning of my function, I see that when I printed I is 0. And what's 0 times anything? It's 0, right? So that's probably the reason why counter is never going to be any other number. So then what I might want to do is go back to my function, say, okay, well, actually, I want to start it at 1. Is that going to solve things? Not quite, because counter is still 0 here. So let's set that to 1, for instance. All right, so we kind of want to reset our debugging tool. So then let's quit. And then what we can do is we can GDB debugging again, put a break at main, and then run debugging again. Next, next, next. Let's click next a few times, and then we'll print counter, see that we did not correctly make the file again, right? So even though we changed the source code, then we actually didn't update our executable. So I believe that you can actually make, within GDB itself, you can actually make the file. So you don't actually have to quit GDB again. You can go back to the source file, save it, back in GDB, you can make it again. Great. So let's run debugging. We want to start from the beginning, right? Because we have a new executable. We can go through a couple of times, and then print I, print counter, continue. All right. So now we see that counter is actually increasing its value as we want it to. So that's just a tiny little bite-sized example of how you might use GDB to enter your code, print certain values, go, click next to proceed to the next line, and abbreviate it and print it out. So obviously, the code in Scramble is a bit more complex than that. But what you can do, for instance, is set a breakpoint at. For instance, your lookup function, something like that. So whenever it reaches the point where it needs to look something up, then GDB will run everything up to that point, and then you can start printing values out. Like is marks at this point false, or is it true? That's probably something that you might want to use. So GDB, don't stress too much about it, because we will go into more detail in lecture, but I just wanted to let you guys know how you might be able to use it if you're getting started with the pset and kind of want to understand in like a better way than just putting printf statements and kind of littering them all through your code, having GDB to actually print it for you, and kind of being able to set those breakpoints so that your program can run up into a certain point and then allow you to really step into it and kind of figure out the problem there. Right, so then if we look back to Scramble, we've read the distribution code. We've talked about a way to iterate over 2D arrays, and so you'll definitely be wanting to iterate over the 2D array when you come to drawing your game grid. We talked about the lookup function, about how we want to make sure of a couple of things. We want to make sure that we haven't been to the word before. We also want to make sure that it's actually in the dictionary. And then we talked about Scramble, about how we want to rotate the board, and so knowing that you kind of might want to make a copy of something to be able to move it. And then finally we talked about case insensitivity, about how you want to make sure that despite whatever combination of case that the user inputs, that if it's a valid word in the dictionary, then it's going to be found correctly. So then all of that together is the Scramble pset, and that is walkthrough 3. Thanks everyone for coming, and good luck with Scramble.